On our next few problems, we're going to be simplifying things with radicals. Something is simplified when it meets these three criteria. All possible factors have been removed, we don't want any radicals in the denominator, and the index of the radical is reduced as much as possible. So we'll see some examples here of how to do that. So we want to simplify the square root of 32. Now, obviously, that's not a perfect square. So there's two ways we can approach this. You can either recognize that 32 is 16 times 2, and so you can pull that apart, root 16 times root 2, and then the square root of 16 is 4, and then you have root 2. So that's one way. Honestly, that's not my favorite way, and probably the way you did it in Algebra 2 last year is you did a factor tree, and honestly, when I'm doing it, I usually go with the factor tree first. So here's the factor tree method. We take 32 and we say, oh look, that's 2 times 16. And then 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. Since this is a square root, our index is 2, we're looking for pairs. So anything that is a pair gets to come out. So we get to bring out a 2 and a 2, and anything that's left over has to stay inside. So you end up with 2 times 2, which is 4, and root 2. So two different ways to get the same answer. Either one's fine with me. I tend to use the factor tree more often. So for example, in B, if you're going to do the factor tree method, we can start with, 25 times 10. So that's 5 times 5, and this is 5 times 2. Now, since our index is 3, we need groups of 3 in order to be able to come out. So we can pull out a 5, and the 2 stays in. Remember, it's a cube root of 2. So there's our answer, 5 cube root of 2. All right, in C, we can do a similar thing. I'm going to do a factor tree here. So that's 6 and 4, 3 and 2, 2 and 2. So it's a square root, so I'm looking for groups of 2. We can pull out a 2. And a 3 and a 2 have to stay in. We multiply those numbers. So 6 stays in. Now, with the a to the 5th, we have a couple options here. You can think of it like a factor tree. A to the 5th is a times a times a times a times a. So we'll list out all 5. We're looking for groups of 2. So we can bring out 2 a's, which is a squared, and 1 a stays in. The other way you can do this is the square root, so that's the index is 2. You can take this 5 and divide it by 2. So 2 goes in there 2 times. That's how many get to come out. And then whatever the remainder is, that's how many stay in. Okay? And that's helpful if you have a bigger number. If we had like a to the 25th, I'm not writing out 25 a's. Okay, so the division method is just a little shortcut. Okay, in D, I'm probably going to do a factor tree again. I don't know. Let's see, that's 5 and 27. 27 is 3 and 9, and 3 and 3. I am looking for groups of 3, so I can pull out a 3. 5 stays in, cube root of 5. And then we're looking at the x. That's 3 x's. We're looking for groups of 3, so we're just going to bring out 1x. There's no x's left over, so that's good. And the only other thing we have to worry about is this negative. Since it's an odd root, cube root is an odd root, that means our answer is going to be negative. Had this problem been an even root, if it had been the 4th root or something, you wouldn't have been able to do it because it would have been a negative number inside there. Okay, last couple of these. We want to simplify these things. Notice these have addition and subtraction in them. You can only add and subtract radicals that are alike, like radicals, we're going to call them. Okay, so as 11a, 3 root 8 plus root 18, as it is right now, you cannot add those. So what we're going to do is do our factor trees, simplify, and see what we get. So the 8 is 2 and 4, 2 and 2, so I can bring out a 2. There's already a 3 out there, so that gives me 6 root 2. For 18, that's 2 and 9 and 3 and 3. So I can bring out a 3 and the 2 stays in. Now, I have like radicals. I have 6 root 2 and 3 root 2. So you can treat the root 2 kind of like an x. Like what's 6x plus 3x? Well, that would be 9x. So what's 6 root 2's plus 3 root 2's? Well, that's 9 root 2. Okay, so you add the numbers or subtract the numbers here. The radical stays the same because they're like radicals. Let's take a look at B. I'm going to factor tree again. This is 9 and 9, so 3, 3, 3, 3. Okay. So I can bring out a 3, and a 3 stays in. And then with the x's, 2, 3, 4, 5, I can bring out an x, then 2 stay in. Sorry, that's a cube root. Okay. That's what I've got there. Okay. Over here, factor tree, 4 and 6, 2 and 2, 2 and 3. So I can bring out a 2. 3 stays in. Now over here, I've only got x and x. I don't have any groups that can come out of that, so I'm just going to leave that as x squared. Cube root, sorry. Okay, so if you notice, I do have like radicals. The cube root of 3x squared. However, I want to subtract 3x minus 2. Those aren't like terms, so I can't subtract those things. So I have two options. Either you can leave the answer like this, or you can say, look, I want to subtract 3x minus 2, but they're not like terms. So I'm just going to kind of leave it that way and then do the cube root of 3x squared here. So that's another option. Honestly, I can't remember what the book does, but if you're doing these for me, I would totally accept either of these answers.